Have you ever wanted to teach a computer how to count? Have you ever wanted to count in letters? If you answered yes to either of these questions, congratulations. You're very weird, and you're just like me. Hey guys, what's up? So I have a program that I've been working on for the last couple of days, and I kind of wanted to show it off. So I was kind of thinking of the question, how do computers count? And I know that seems like a basic question, but I really was kind of curious because counting, when you think about it, is not actually all that easy. I mean, yes, you're just adding one and saying what it is, but what happens when you get to 9? And how do we even know what 9 is anyway? Here's my thought process. Obviously, you got to code a computer to do numbers more than 0 and 1 because computers run on binary. So you can tell them, okay, well, you have these numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and they have values. 9 is greater than all the numbers, and 1 is less than all the numbers, but it's greater than 0. You can tell it those things. And then you can say, okay, count from the lowest to the highest. But what happens when it reaches 9? When it reaches 9, it goes to 10. But 10 is kind of weird. It has 2 digits. It has a 1 and a 0. So what's up with that? And it's just, I was wondering this question, like how does a computer know to create 2 digits and then only increment the second digit until it reaches 9 again, and then increment the first digit, but also reset the second digit? It was all very confusing to me. So I wanted to see if I could actually program this myself. And I was able to get it working perfectly. So I have a couple of example alphabets. I called them alphabets, but it's really just a set of numbers. So like base 10, that's the number system we know, 0 through 9. I have binary, trinary, hexadecimal. I included the music alphabet for some reason, the English alphabet, and alphanumeric, which has all the numbers and letters. So here's how the program works. I'll show you how it works first, and then I'll go through the actual coding. So if we run it, it says, what alphabet would you like to use? And I'm just going to say, let's do trinary this time. And it says, how many seconds would you like to between prints? Let's do 0.1, so it goes pretty fast. How many numbers would you like to print? We'll just do infinity. And what number would you like to end on? We'll also say infinity for that, and infinity for number of digits. And as you can see, it's now counting in trinary. It's going 0, 1, 2, and then it's going 10, 11, 12, and then 20, 21, 22, and then we get 100. And that's kind of how trinary works, because there is no 3 in trinary. You have 0, 1, and 2. And so I'll run that one more time with a different one. We'll say, let's use the alphanumeric one. Let's do 0.1 again, and then use all the blank. So you can see it goes up to 9, and then it starts counting in letters. And then we hit 10, and then we start going into the 1 letters, and then we hit 20, and then the 2 letters. And so you can see it's counting with numbers and letters together. So here's kind of how the coding works. This is the most important variable right here. It's called indexes. And originally I had this as just a single integer, but I decided to make it a list because it works a lot better for this. Because once we get into multi-digit numbers, you've got to have multiple digits that are able to work together and reference each other. So I decided to include them in a list. This basically is just a variable that holds what I'm going to print. I have a position for when we're changing things. This is the numbers printed in case the user sets how many numbers they want to print. And then I have the list of alphabets in the list of lists of alphabets in a list. I know that's kind of a mouthful, but it's a list of lists. And then I have a list of strings that are the alphabet names. So basically, first it just asks you all these questions and gets your answer. And then here it adjusts the variables if needed. So for example, if you type out the name of one like I did, then it will just choose that one, or you can actually put in the number of which one it is. So like I could say, oh, well, I want English, so that's number 6, and then that will work, right? And then you get English alphabet. And if you don't type in anything, it'll just default to base 10. It'll set the speed, but if you don't set anything, it'll default to 1/10 of a second. And this is an interesting thing I found. So for example, if we are using the English alphabet, watch this. When you hit Z, it goes to AA, because A is the first one. So it adds an A and then another A. But let's say we're talking about regular numbers. After we hit 9, we go to 10. Why don't we go to 0, 0? And so basically what this is saying is if the first character of the alphabet is a 0, then we're not going to include it when we start a new number of digits. But if otherwise, we are going to include it. So then here's the core loop. This is where all the logic happens. And I found it fascinating that it's this complicated because lots of little kids can count 1, 2, 3, 4, 5, but really they're doing this entire block of code when they're just counting. And so I found that very fascinating. So here's what happens. Once we start it, it's going to wait that tiny amount of seconds. And then I added comments on every single line because this is very complicated. It references a lot of things that are referencing other things, so it gets very hard to understand what we're doing. So this is the delay to make it readable. And then I have a couple of if statements because it's going to keep looping back to here. So if the number of digits we have has been reached, then we're going to exit the program. Well, there's two if statements here. If there is a limit for the number of characters and we've reached that limit, then end it. And then there's the next two if statements. If the user has added a limit for how many we want to print, and if we've reached that limit, then end the program. Otherwise, we're going to actually start the process. So for everything in indexes, which is basically holding our number form of whatever we're doing it, so like the alphabet has 26 letters. So in indexes up here, this letter or this number could actually go up to 26, even though we only have 9 numbers in the base 10, because that digit can go up to basically infinity. So for each number in that indexes, we're going to add it to this thing called thing to print, which is the thing we're going to print. So that's basically creating our number. And then we reverse it because we actually created it backwards, and then we print it. And that's actually fairly simple. We're just making a number and printing it. The complicated part is how do we modify our previous number to make a new number that is the previous number plus 1. You would think it's pretty basic, but what we're trying to do is we're trying to accomplish that, but avoid doing just plus 1. So that way we can actually use letters to count, which is kind of the whole point of this. So if the user is saying, oh, well, I only want a certain number of things, then we increment this because it's been printed. And then here's another if statement. If the user says, oh, well, that's the last item I want. And if the user says that, and if we've reached that item, that's the last item, then we're just going to end it. So next we get this, we reset the thing to print and we reset the position. Now this whole block of code right here, this is what changes our number. So once we've printed it, we're changing it now. So we say, okay, we're going to start going through each number in indexes, which is, remember, our list of what numbers, what digits we're using to create the number. So we're going to go through those one by one and modify them if needed. So we start at the smallest number, which is, it's kind of backwards. So like if I were to, let's pretend it's base 10. If I were to do 1, 2, 3, this number would actually be 321 because it goes in backwards order, which really helps us right here. So we go down here and we start at the rightmost number, which is the first number in indexes. We say, okay, is it less than the maximum number we have in our alphabet? And if it is, we just increment it by 1 and start the whole thing over. Pretty easy. But what if it has become the max? What if that's our 9? We can't just say 9 plus 1 because that's not going to work. So what we're going to do is we're going to reset it back to 0. And then we're going to check, okay, well, is there a second digit already created? And if there is, great. We're going to just add that number to 1 and increment it. But if that number doesn't exist, we have to create it. So if that number doesn't exist, this is going to generate an error. Because if we add 1 to our position, but position plus 1 doesn't exist, it's going to create an error. So if that error happens, we're going to instead create that new number here. And then here's where that include first part comes in. So if we're including the first character, then we're going to just start over because it's going to include that character automatically. Otherwise, it's going to need to run through this process again to increment that number by 1. And then finally, we're going to update our position so that if needed, we can move over to the other numbers. So as you can see, it's not too long. It's only 91 lines, but still, for a program that literally counts, it's pretty cool. So, just for one more example, now that you understand how it works, let's do music for fun. And then I said, okay, we can actually put in 0 seconds. It'll just go as fast as possible. And I always find that satisfying. You can see it goes super, super fast. Kind of starts to lag out if you let it go for too long. Anyway, thanks for watching, guys. I hope you enjoyed, and have a nice day.